a long video, but I'll try to hurry up, and you guys can obviously use your fast forward function. Okay, so the first question, we did it in class, so think about this. What values, so this one is pretty simple. What values of x can I put in there? Well, that make that inequality true. So we have, if you think about this, what values can I put in here? Well, 2 would work, right? 2 works in there. -1 works, 0 works, absolute value of 1 works, absolute value of 2 works, but notice that absolute value of -2.11 works because absolute value of 2.1, -2.1 would be greater, so that's not part of our solution. So our solution is, and this one is simple, x can be any number between -2, oops, what kind of number line is this? -2 and 2. Okay, so we can write it in this manner. So any value between those two would make the inequality true. Next one is x plus 3 greater than 4. So again, I want you to ignore that for a second and just think about what values can I put in here to make that inequality true. Well, greater than 4, so we're looking for values greater than 4. We make that 4.1, 4.2, 5, 6, 7. So we got a point that way. 3, 2, 1, any number between 4 and -4 will not work, right? But when we get to -4, a number lesser than -4, like -4.1, that would work, right? Because if you take the absolute value, that's 4.1. 4.1 is definitely greater than 4, so we go that way. So if you understand that, now you can come back here and we know what our values have to be, right? So numbers greater than 4 or less than -4 makes this inequality true. So what can I replace x with? So can I make x be 5? So if I make x is 5, 5 plus 3 is 8, and that's greater than 4, so that works. So 5 works. What about 10? 10 works. 10 plus 3 is 13, and that's greater than 4, so that works. What about 0? Will that work? Well, 0 plus 3 is 3, and 3 is definitely not greater than 4. So there are certain values of x that doesn't work. We want the ones that work. So in this case, x plus 3 has 2 conditions. This x plus 3 has to be greater than 4, or x plus 3, and what do we write down here? That it has to be less than -4. So yeah, 2 conditions. So -3, x is greater than 1, -3, x is less than -7. So we draw a line, a number line. These are all the values of x that you're representing that we can plug in here, add to 3 to equal greater than 4. So as long as you pick an x value that is greater than 1, let me put a 1 here, or an x value that is less than -7, that works. So pick any number less than -7, plug it in here. Let's say -20. -20 plus 3 is -17. Take the absolute value down, you get 17, and that's definitely greater than 4. Above 1, I don't know, pick 3. 3 plus 3 is 6. Absolute value of 6 is greater than 4, so that works. So here's my solution for the x value. So, and we can represent that as 1 not inclusive going all the way to infinity. And over here it starts at -7, and aiming to the left it goes to -infinity. And again, not inclusive, and the union, right? X plus 3 less than -6. So this one's so when is the absolute value of anything ever less than -6? Never. This will never ever happen. You can, there's no number that I can put in here that I can take the absolute value of and be less than -6 or less than a negative number. That will never ever happen. So this one, there's no solution. There's no value of x that I can put in here to make that inequality true. Okay, so that was simple. 16, 3, 2x minus 4 greater or equal to -9. So remember, let's get rid of the 3, divide by 3, divide by 3. 2x minus 4 right? We got rid of the 3's. It's greater or equal to negative 9 divided by 3 is negative 3. Again, so now that we're in this position, so again, just let's imagine this. Forget the 2x minus 4 for a second. Let's just think of a number that I can plug in here, take the absolute value, and so that when I take the absolute value, it's greater than negative 3. Well, 0 works, 1 works, 2, any number actually, right? Because the absolute value of any number is a positive, or actually 0, including 0, and 0. So this is x belongs to all real numbers, right? Or it's all real numbers. Doesn't matter what number you put in there, it will always be greater than the negative number. Okay, so you can take the absolute value of anything. Okay, so it really doesn't matter what you plug in for x. It's going to be every single number out there. Okay. Ooh, 17, 2x minus 9 plus 6. All right, so minus 6 on both sides. So let's get rid of the constant here. So we are left with 2 times absolute value of x minus 9 greater than 0. Divide by 2, divide by 2. X minus 9, oops, greater than 0. So when is the absolute value of anything ever greater than 0? Well, except for 0, right? So if you think of a number line, let's put a 0 here. Does 0 work if I put it in here? No. So I'm not going to shade it. But does 0.1 work? Yeah. So numbers greater than 0 works. And guess what? Number less than 0 also works. So now what can I plug in? What can I replace x with? Subtract by 9 so that it's greater than 0. That's what we have to find out. So there are two conditions. One, x minus 9 can be less than 0. Right? You see it over here. And x or, let me put an or, x minus 9 can be greater than 0. We do plus 9, and we're going to get x is less than 9. And over here, plus 9, and we're going to get x is greater than 9. So on the number line, it looks like this. Here's 9. 9 doesn't work. So let's put 9 here. 9 minus 9 is 0. Absolute value of 0 is 0. So is 0 greater than 0? No. So 0 definitely doesn't work. Now, let's put 9.1. 9.1 minus 9 is 0.1. And 0.1, absolute value of 0.1 is 0.1. Is that greater than 0? It is. So numbers. So if I pick any number above 9 and replace that x with that number, that's going to be true. And likewise, if I pick any number less than 9, it's going to work. So let's try 8.9. So if you think about it, 8.9 minus 9 gives me negative 0.1. Absolute value of negative 0.1 is 0.1. Right? Sorry, is 0.1. Is that greater than 0? Yes, it is. So, so that's it. Okay. In this case, we have 0, not inclusive. We're going to go all the way to negative infinity, right? Going to the left. And on the right side, we're going to go not 9, not including 9, and any number greater than 9 going to positive infinity will work. 18, negative 4, 3x minus 1, greater than 8. We're just going to divide both sides by negative 4. That goes away. We're left with 3x minus 1. And then if we divide that, it's going to be, we're divided by negative numbers. So first of all, let's switch that in the equality sign. We get negative 2. So again, this is similar to a question. I forget which number it is, but similar to a previous question. Think about it. When is the absolute value of a number less than a negative value? Think of a number that I can put in here, take the absolute value, and it's going to be less or equal to negative 2. That will never happen. Never. Because every single number I take the absolute value of will be greater than negative 2. So since it never happens, there's no solution. Ooh, I just forgot what number we did. Okay, so 19 is next. Negative 5, 2x plus 2, and then minus 3, greater or equal to negative 3. So let's do plus 3 on both sides. That goes away. I'm left with 0 over here. negative 5, 2x plus 2. We're going to divide by negative 5. Divide by negative 5. So that simplifies to 1. And finally left with 2x plus 2. We divided by a negative number, so let's switch that, and that becomes 0. So when is the absolute, again, think about this, let's take that, forget the 2x plus 2. When is this ever true? When is the absolute value of anything ever going to be less than 0? Well, this is the only number that works here is 0. So if you think about it, if I put 0 in there, does it work? Yes, because 0, it's not less than 0, but it's definitely equal to it. So 0 works. I'm going to shade it. Now, let's look at numbers to the left of 0. Oops. To the left of 0 and to the right of 0. So let's pick 1. If I pick 1 over here and put 1, will that work? No, because 1 is definitely not less than 0 and definitely not equal to 0. So 1 doesn't work. So numbers on this side doesn't work. How about negative 1? Well, the absolute value of negative 1 is 1. Is 1 less or equal to 0? Also, no. So the only solution here is 0. Okay, so I think that's how you would write it. 0, that's it, and inclusive. Right, I might double check on that. Okay, I'll double check on that. But 0 is the only possible solution. Okay. So actually this one, you can actually write x has to be equal to 0. Okay, so, sorry. So when I come back to my inequality, when I set this inequality, 2x plus 2, it can't be less than 0. It can't be greater than 0. So in this case, when I set this, I set it has to equal to 0 because it's the only time this will work, right? So if I do minus 2, that goes away. 2x equals negative 2. Divide both sides by 2. And x equals negative 1. So I have one value in this world that will make this absolute value true. So let's plug in negative 1 over here. So if I plug in negative 1 over here, I get 2 times negative 1 plus 2. And that's less or equal to 0. 2 times negative 1 is negative 2. Negative 2 plus 2, less than 0 or equal to 0. Negative 2 plus 2 is 0. And if I take the absolute value of 0, isn't that 0? And isn't 0 equal to 0? So that works. There is no other number that will make that inequality true. So my only answer is x equals negative 1. So again, let me double check. That would be the only one. Okay.